What is y? When you graph stuff on a Cartesian coordinate, that's this xy thing, well, there it is. That's your y coordinate. We also know now it's range, it's part of the range. It's the output given the input, okay? It's just y. It's a y coordinate. Same thing with x. That's just the x coordinate. But now you know it's called the domain or the input, okay? M. Remember what that is? Some of you do. Calvin, what's M? Slope. That's the symbol for slope. We've been doing that for a little while, okay? And some of you guys kind of know it, looking at that last little quest thing we had, and some of you, okay? Well, we're still doing it. So, good news. Okay, that's the slope. That's just the slope. That's just a number. It's rise over run. If this was 4 and that were 2, the rise over the run would be 4 over 2, which we know we can simplify it as 2. That's the slope. It's just a number. This is the new one, little b. What the heck is that? Well, what does that say? Could it be that simple? Slope, y-intercept form. There's the slope. Guess what that is? Have we done a y-intercept before? Hey, there's one. What always happens at the y-intercept? X is 0. Have we heard that before? Yeah, maybe. Okay. So, I'm saying this a little slower than usual because, you know, we've had like a nice big holiday. By the way, I do know someone who went to Hawaii for basketball. This is in a school in the Lower Mainland. Okay? It was supposed to all be organized. They were going to play some United States basketball teams in Hawaii. Does that sound like a fun little basketball trip? Yeah. They had no games to play. Whoever organized it didn't organize it very well. And then, you know, hey, this doesn't work. Well, let's just veto the Canadian team. Who cares? So they ended up getting one scrimmage with some other team somewhere. But, yeah, it was just like, what? So anyway, they just couldn't play any basketball. They had to just, you know, do boring things like lie in the sun and hang out. Yes, surfing, that kind of, you know, that stuff's terrible, right? So anyway, it's kind of odd. Okay, investigating the graphs of linear makes a line and nonlinear doesn't make a line, i.e. curved relations. Okay, use a graphing calculator. In some places like Alberta, everybody has one. You're required to. All right, here we don't. And you don't need one for this course. So just trust me here. I'm going to quickly graph these guys. You see this one here? How would I find, any guesses as to what that is, by the way? Y equals mx plus b. Y equals mx plus b. Did I say what that was already? Yeah, well, let's quickly figure that out. What happens at the y-intercept? How do I find it? X is 0. Let this be 0. What's the y-intercept? There it is. Okay? This is a 3x. If we graph this, it looks something like that. Okay? Just trust me on this. You don't have a graphing calculator, but if you did, you just plug it in. 3. If x is 0, I get that point, right? Okay? This is negative. How does the slope look if it's negative? Kind of looks like this. And it's not quite as steep as 3, so I'm just going to make it a little less steep. Okay? Those look like lines so far? Okay. This one's weird. Let's check this out. That says negative x to the third power. Okay? Negative x to the power of 3 plus 1. Do we think that's a y-intercept still? What happens if x is 0? I get negative 0, which is a 0, plus 1. Yeah, there's that. Let me hit graph here. Pretty funky, eh? It's not supposed to be funny. It's just, you know. right? If I want to make that a little clearer, what if I go x negative 5, 5. Okay, you guys will be using one of these things in grade 11, so it doesn't hurt to show you this. All I got is one question. Does it look like a line? No. It looks like a funky S. Okay, that's what this thing does. Looks like that. Oh, hang on. Why did that go through the origin? Because I didn't put +1. My apologies. Okay, now it looks like it goes through the y-intercept of 1, right? Okay? X squared. What does that thing look like? X squared minus 3. Any ideas what the y-intercept might be? Graph. That looks pretty straight, doesn't it? I am being sarcastic. Definitely not. That is what we call a parabola, okay? 1 over x, that one's really weird. Who remembers exponents? How can I make that x? I want to bring it to the top, okay? I want it to look like this. This isn't over x. This is something, some coefficient, times x. How do I bring that up? How do I flip it to the top? Yeah. That's what that thing looks like, okay? That's the same thing as 1 over x. What does that guy look like? Let's have a look. If I go x to the power of negative 1, cool, eh? Does it look like a line? Definitely not. It does that, and it does that. By the way, just looking at this, if x were 0, what's 1 divided by 0? Can we do that? It doesn't exist. That's why you can't find that y point on this graph. Okay? If x is 0, well, where does this thing cross the y-axis? What's the y-intercept here when x is 0? There isn't one. Can't do it. Doesn't exist. Okay? But I just have one question. Does it make a line? No. So that's all we're doing here. We're investigating what's going on. Negative 2. That's the y-intercept. A slope of a half, positive. If I graph that, that's what it would look like. 4 times x. What's the y-intercept here? Let x be 0. There it is. A slope of 4, that's pretty steep. 2 to the power of x, I'm not even going to bother. Okay? So, list the equations which are linear. I'm just going to circle the linear ones. Okay, we got to know why it's linear. That's linear. That's linear. Nope. Nope. This one's linear. That one's linear. Nope. And I'm not even bothered with that one. Okay? Does anyone see a pattern? How do you know, looking at an equation, whether it's going to make a line or not? Because some of these do and some of these don't. What's that thing called? That's an exponent of what? It's an exponent of x, but like what's the number? It's a 3, right? This guy, exponent of 2. What's this exponent? Negative 1. Okay? So those are the guys that don't make a line. The ones that do, what's the exponent of x here? What's the exponent of y? 1. Does that thing happen here too? Okay, there's a line. What's the exponent of x? 1 and a 1. What's the exponent of x? 1 and a 1. That's how you tell if it's going to make a line or not. I.e., if it's in the form of this, what's the exponent of x? What's the exponent of y? Okay? That should be an easy mark. That's just something to remember. All right? Compare the lists. Write a rule from the equation used to determine whether the graph is a straight line or not. If exponents of y and x are 1, it is linear. Okay? i.e. makes a line. And what's the converse? Well, if it's any other exponent, it doesn't make a line. Okay? And if you have a graphing calculator, you can prove that to yourself. They're not banned on the tests, right? But not many of you do. Okay? All you'd have to do, but you still need to know how to graph it. I never taught you that. Okay? That's it. How about this guy? 3y is minus 2x minus pi. Is that going to make a line? Is that linear? It's linear if the exponents of y and x are 1. What's the exponent of x here? Yeah, what's the exponent of y? She makes a line. She's linear. Okay? An example of something that's not similar to the one I just kind of gave you. Yeah, don't get confused. This is a 1, but I can't write it like that. I have to write it like this. Okay? Because x has to be on the top, not the bottom. This is not 1. This is a negative 1. Okay? That's not linear. Doesn't make a line. All right? So, linear equation. This is just one form to write a linear equation. You've graphed these already. Okay? You know how to set up an x and a y table and graph whatever the heck this says. Okay? Y is 4x plus 2. Put in values of x, solve this for what y is, get a bunch of points, and make a line. Okay, you know how to do that. We know that's linear because x and y are both 1. Okay, so let's see what's going on. I already told you what this stuff is. Janine used a graphing calculator. She plotted this. That's what she got. Okay? Use the sketch in points A to B to find the slope and the y-intercept. Well, here's A and B. You can use any points. I could have used that one too if I wanted, right? You know how to do this. I hope you remember. Make yourself a little triangle. What is the slope? Slope is rise over run. What's the run here? Sorry, what's the rise? 2. What's the run? 1, 2, 3. Is that positive? Yes. If it went like that, it would be negative, right? Okay. Do we see where that's in the equation? See that 2/3? What a shock, eh? Y-intercept. You could look at the equation and solve it, or if it's given to you as a graph, where does it cross the y-axis? Right there. Here's the y-axis. So that's a value of -1. Okay? The y-intercept is -1. Let's look at the equation. That's where x is 0. Y is 0 times 2/3, which is 0, minus 1. Yep, it's -1. There it is, right? Okay? But if you got a picture of it, just look. Compare those and the constant found in that equation. Well, where's the -1? It's right there. Okay? So that's why this is a good form to write the equation of a line, because it's helpful. It tells you what the slope is. It tells you what the y-intercept is. It's useful. Okay? The other forms aren't as useful. That's why this is called, what did it call it? slope y-intercept form. Because there's the slope, there's the y-intercept. Okay? This is the nice one to have. Okay? I think I want to skip that guy. Part 2. I know it's a funny word, but some people in the world are called that. He used a graphing calculator. He graphed this thing. Okay. Use the sketch to determine the slope and the y-intercept. They're giving you 2 nice points. Here they are. Let's make a triangle. What's the slope? What's the rise here? 1, 2, 3, 4, 5. What's the run? 1, 2. Is it positive? No? Yeah, that's positive, right? If it goes up to the right, that's positive. Okay? If it goes this way, that's negative. So that's positive, that's the slope, 5 over 2. Note, I don't really see a 5 over 2 there, do I? What's the y-intercept? Where does it cross the y-axis? Right there. What's that value? Well, they didn't give you the origin, but it looks like it's right there, right? 1, 2, 3, 4. And we could also find that if I let this be 0 and solve that for y, I hope you see that would be 4 too, right? 2 goes into 8 4 times. Divide both sides by 2. Okay, do you see a 4 in here? No. So why is that? Because this is not in the form y is mx plus b. It's in the form 2y is something x plus something. Okay? This only works if that's a 1. You can't have any other number there. Okay, so that's answering this question. Explain why. Okay, because you got to sort this thing. You got to arrange it in terms of y by itself. So how do you do that? Well, let's do it. 2y is 5x plus 8. How do I get y by itself? How do I get rid of that 2? By dividing it away. It says 2 times y, so you always do the opposite operation, right? Divide by 2. So y is 5x plus 8 over 2, but we don't want to write it like that. We want to split that up. Okay? I want the 2 under both of these things. Okay? Is that the same thing? Are you guys okay with that? If you're not, remember, when you're adding fractions, if you have the same denominator, you're just going to carry that over and you're going to add the tops, right? That, of course, is 3/4. This is exactly the same thing, only I'm going the other direction. Okay? I want to write this not like this. I want to split it up into 2/4 and 1/4. Why? Because then it's in the form y is mx plus b. Okay, there it is right there. Now that tells you what the slope is. Is it 5 over 2? Yeah. The y-intercept, is it 4? Yes, it is. Okay? So y equals mx plus b. Remember, this y has to be having a coefficient of 1. Okay? If there's another number there, you got to get rid of it. You have to change it. All right? So this has already been said, but let's just throw a little highlight there. This is slope y-intercept form. Again, it's the most useful form for an equation because it tells you what the slope is, tells you what the y-intercept is. That's what all this says. Okay? So if you're given this form, you can just draw the line, right? That's what we're going to do. So first, this is slope-intercept form. Determine the slope and the y-intercept. What's the slope here? The slope is m. As long as that's in this form, you just look and you see what the number is, right? And it's in that form. So the slope is 3. Okay? What's the y-intercept? It's 2. But what's our symbol for y-intercept now? We don't have to write out y-intercept. We got a letter. It's b. Okay? So b, the y-intercept, is 2. Is that in the form y equals mx plus b? Not quite. That says y equals b minus mx. How about I just rearrange it? Y equals mx plus b. Is that the same thing? Yeah. All I did was rearrange it, okay? So what's the slope? Negative 2/3, and the y-intercept is 7. Okay? Last one, that's like this one up here that Hashib did. Okay? I don't know what the y-intercept is here. I don't know what the slope is because there's a 6 here. I got to get rid of that. How do you get rid of the 6? It says 6 times y, so divide. But let's just do this first. Okay, whatever you do to one side of the equation, you have to do to the other side of the equation. Let's just put a 6 under every term. Then y is by itself. That's my slope. That's my y-intercept. Don't worry, it doesn't have to be an integer every time. It can be a fraction. But don't make it a decimal, just like before. Just leave it as a fraction. Okay? Unless that's really hard to plot, in which case, if decimals make more sense, then, you know, make it a decimal. If someone's asking you to graph it. Okay? But can I reduce this 8/6? Yeah. 2 goes into that 4 times. 2 goes into that 3 times. That's 4/3. You're going to want to reduce it if you can. Okay? So my slope is 4/3. My y-intercept is 1/6. Okay? All we got to do now is graph these. And that's a lesson. Graphing. Consider this equation. What form of the equation of that line is? First of all, is it a line? It might not be. Is it? Yes, because these are both exponents of 1. That's going to make a line. Okay? And if you got a graphing calculator, you can plot it. What's the slope? What's the y-intercept? M is the slope. That's 2. Okay? Because this is in the same form as this. B, that's the y-intercept. That's -5. Okay? How do we graph this? See, I know the slope is 2. And again, if that's helpful, you need to know the rise and the run. That's the same as 2/1, right? See, you can't start with the slope. Because what point do you start with? Don't write this. But if I started here, 1, 2, there's the rise, there's the run. Okay, there's 2 points. That's all I need to do a line. Or maybe it's over here. 1, 2, there's a line. Maybe it's down here. 1, 2, there's a point. There's the line. Those all have a slope of 2. But they're all wrong. How do you know where the line is? Because it has to go through that point. That's the y-intercept. It has to go through the y-intercept, which is right there. So that's where you start. Okay? Step 1. Always, always, always start with the y-intercept. Mark it on the grid, right? That's where it crosses the y-axis. It has to be a point on the line. Then, step 2, use the y-intercept and the formula to mark 3 other points on the grid. All you need is 2 points to do a line, but unless you got a really nice ruler and you're really careful, do a lot more points, right? Okay, the slope is 2 over 1. Rise is 2, and run in the positive direction, I go to the right. Okay, we've done this before, right? All right, let's do another point. Rise is 2, run is 1. Rise is 2, run is 1. 2 and 1, 2 and 1, 2 and 1. Can I go the other direction? You bet. Because if you got a point up here to start with, how do you do the next point to make your line? You would go rise 2, run 1 in the positive direction. So I can go rise 2, run 1, 2, 1. There's your line. Okay, nice sloppy one, but there it is. And you should do arrowheads on there. It keeps going forever and ever and ever, right? Little bit of review. What's the domain of this? When I gave you that question before, a lot of you were confused. Okay? Now you shouldn't be. Is there any value of x I can't put in there? Name a number, any of it. I can put that in there for x and solve for what the value of y is. Okay? X is all real numbers. There's no restrictions. I could put 1,034.6 in for x, solve this for the output for y. Okay? I could put in negative 50,012,000,000 and get a value for y. Okay? There's no restrictions. Same thing for the range. Okay? All real numbers. There's arrowheads here. This thing goes on forever and ever and ever. Okay? All you need is 2 points to graph it, but don't just do this. Okay? Don't go, yeah, there's my line. No, that's not this equation. That's just a segment of the equation. Okay? That's the line. All right? Just because I can, because I have one of these, let's have a look. 2x minus 5. 2x minus 5. Does that look similar to that? Not really. Let me fix my window first. Looked a little steeper. Now does it look the same? You bet. What's the y-intercept here? Negative 1, 2, 3, 4, 5. Bang on. Okay? Where's the x-intercept? Looks like 1, 2, almost 3. Does that look the same here? 1, 2, about 2 something? It's hard to say. We could find it. Okay? Let's not ask that. All right, one more. This is important. Definitely you will be asked this several times before this course is out in the next 15 days. Consider the equation. All it's going to say on the test, guys, is graph. Or there's going to be a picture of 4 graphs, and they're going to say, which one is that? You should be pretty quick at this. What do you do first? What's step 1? You know it has to go through that point, negative 6. That's step 1. Okay? Step 2, it's got a slope of 2/3. That's rise over run. Positive. So you go 1, 2, rise, 1, 2, 3, 4, run. Okay? There it is. And my past experience would say, if you're given 4 choices and multiple choice, that'll be one of them. That'll be the other one with a y-intercept of -6, but negative slope. That'll be the other one, the right slope, but the wrong y-intercept, +6, and that would probably be the other choice. Okay? Should be an easy mark. All right? Let's do this a different way. How many points do you need to do a line? We've already done this. What are 2 points on this line? How about the x-intercept and the y-intercept? Okay? Pretend today didn't even exist. How do you find the y-intercept here? The y-intercept, that's where x is 0. Y is 2/3 times 0 minus 6. The y-intercept is minus 6. There's 1 point. That was a bad line. Didn't even go through my point. Okay? The x-intercept. What's the value of y at the x-intercept? Right? Always, always, always. I don't know where this line crosses the x, but y is always 0 here. Okay? So, 0 is 2/3 x minus 6. I got to solve that guy for x. How do I do that? Get rid of the minus 6. Add it to both sides of the equation. 6 is 2/3 times x plus 0. I know everybody loves fractions. All I got to do is get rid of that 2/3, and I know what the x-intercept is. Okay? That's the tough part. How do I get rid of that 2/3 as nicely as possible? You could divide it away, but don't do this, because that's a little tricky. What is 6 divided by 2 divided by 3? Anybody know? Well, if you had one of these, and again, I don't recommend you do it this way. 6 divided by 2 divided by 3. That says 1. 6 divided by bracket 2 divided by 3. That says 9. One of them's right, one of them is wrong. Okay, that's why I don't recommend you do it this way. Okay, but if you know how to do that, that is the answer. Here's how you should do it. How can I get rid of this 2/3? How do I get rid of just the 2? By dividing it away. It says 2 times x, divide by 2. It also says x divided by 3. What's the opposite of divide by 3? Yeah. You remember this little trick? Multiply it by the reciprocal. What is 2/3 times 3 over 2? It's 1. Right? 3 divided by 3, 2 divided by 2, or if you like, 6 divided by 6. Okay? That's the nice way to get rid of this. Because this is just 1. X is by itself. What's 6 times 3 divided by 2?